Okay, last two problems for this unit, or at least this part of the unit in terms of the skill. So this is where I said you're going to need your calculators. I'm going to show you how to do all of this in the calculator, but there is a setup that I want you to see. So here it says that suppose that at time 0 there are 500 bacteria in a growth medium, and the bacteria population y of t grows at the following rate given, y prime. Okay, first of all, this is the derivative because this is the rate at which they are growing. So whenever you see rate, that indicates that it is whatever you're given there is a derivative. Okay? How many bacteria will there be in 8 hours? So they want to actually know not the rate of change, but they want to know how many bacteria. So if the derivative is the rate, how do I get the number of bacteria? Yeah, you have to integrate. And even if you didn't know that, we're in an integration unit, so that should have kind of been the clue, right? Yes. So what they want is y of 8, meaning how many bacteria there are after 8 hours. Okay, but what you have to consider was that you didn't start off with 0 bacteria. You actually started with how much? 500. Exactly. So this is called an initial value problem. Okay? So let me just show you something really quick. So here's my graph. Okay, and this is just a very rough sketch. This is an exponential graph, right? So that means this is going to shoot up like this. And this value right here is like 305 and change. So remember when you integrate, you're looking for the area under the curve, true? This right here is a rate. So it's the number of bacteria per hour. Okay, so then we're looking for the area under the curve like this. I'm just showing you so that you can understand what's happening. If you don't care, you can just pretend. Okay? And this would be at 8 hours, so this is hours. So if you have bacteria per hour, the hours cancel out. Does everyone see what I'm saying? Because if you have bacteria per hour, this is a complex fraction. So this is, when you integrate, it's going to give you the number of bacteria. Does this make sense? Okay, I just wanted to show you why this is happening. Yes, dear?
Why would that be the case instead of like meters per second,
meters per second? It should be... If it's meters per second, you're fine. That's derivative, though. You're going in the wrong direction.
Okay.
This is integration, so we're moving backwards.
Oh, okay.
So we're looking for the area under the curve, so we already have the rate. So that one, when you're going in the other, it's going to be multiplication.
Okay.
You almost got me.
Okay.
Which is fine, because I'd rather be tested. But that's good, because you're going in this direction, we're going in the other direction. Okay, so here we have our initial value, y of 0, which is, we already know is 500, right? Plus the integral from time 0 to 8 hours later, and I'm just going to write this as y prime of t dt. Okay, and the reason why is they actually defined this. So I don't need to rewrite that whole crazy thing. Because actually, where am I going to put this? Yeah, I'm putting this into my calculator. So I'm not, the less you have to write this, the better you are. Because then what if I make a mistake? Right? Okay, so what you want to do is go into y equals, and you want to put this into, let's say, y sub 1, or whichever y sub you choose. It's really your call. Yes. Okay? And then we're going to integrate that. So I put it here. I double checked it to make sure that I was good. Then I go into my home screen. Bless you. And I go into Alpha Window, option 4. We are finding the area under the curve from time 0 to time 8. My function is in y sub 1, and we are integrating with respect to x. So alpha window gives you the integral. Alpha trace gives you your y sub. Everybody good? Okay, so when I press enter, this is the amount of bacteria that grows over the 8 hours, but what am I missing? Yeah, what I started with. So you got to add 500. So this is how much bacteria we have. It's a lot of bacteria. Could be good bacteria. Oh boy.
Let's just assume it's good.
Okay. Questions? Nobody has any questions? You want to see if you get the answer right? Okay. Questions on this? Because I'm going to move to the next problem. That's the answer.
So you can use a calculator on the test?
When I said that there was a calculator part to the test and non-cal, yeah.
That still leaves 1,000. So for these types of questions, you're allowed to use a calculator? No.
Yes.
Wait, the unit is bacteria, right?
Say what?
The unit is bacteria.
Yes.
Eli said he wants to do it all by hand.
Okay. All right, last example, ladies. All right, I'm just going to keep going, and I lost my pen. Okay. So we're going to find a positive value C such that the area under the graph is 30 square units. I'm just going to keep going. So here, the area under the graph, what does that indicate? Yes, we're going to take the integral. Okay, and we actually have the value. It's 30. It's 30 square units. This is my interval. So can someone say what's another term for this interval? Yeah, these are my bounds when I set up my integral. So find a positive value C such that the integral of this function over this given interval, meaning my bounds, is equal to 30. So this is my setup. We're going to integrate from 1 to C of e to the 5x, excuse me, dx, okay, and this is going to be equal to 30. Before I can put this into my calculator to let it do anything, I need to make a few adjustments here. Well, that's the problem. I have two variables. So in order for me to figure this out, I'm going to have to do a little bit of work by hand, but the rest of it I can do in the calculator. Okay, and this is actually, I'm going to show you how to find this answer in the graph. So this would be a u sub problem. Can you tell me about what my u sub is? It is 5x. So we're going to say u is equal to 5x. So du is equal to 5dx. Do I have to do anything or? Yeah, okay. So I have 1/5 du is equal to dx. So what we have here is 1/5 times the integral of e to the u du is equal to 30. I need new bounds though. Okay? So this is x and this is u. So this is c and 1. So just plug in. If I plug this in for x, what's my new bound for u? It is 5c. Okay, and then what's this one? It is 5. Okay, so this is going to be 5. And this is 5c. Okay, so at this point, I still have to do a little bit of work. Can someone tell me why? I still have two variables. Okay, is it hard to integrate e to the u? No, it's not. So I'm going to leave this 1/5 out here. Okay? When you integrate e to the u, it's just e to the u. We're going to evaluate from 5 to 5c, and this is equal to 30. Okay? I'm not multiplying this by 5, and I'll show you why in just a second. So just leave the 1/5 out here because I want to use the calculator. This is going to be e to the 5c minus e to the 5th power, and that's equal to 30. Okay, up to this point, does everyone understand where this came from? Okay, did this help me get rid of my double variable situation? Double variable. Yes, because what is this? Describe this for me. It's a number. It's 2.17 blah, 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 blah to the 5th power. Okay, so it's a number. So if I put this into my calculator, I only have one variable. And if you have something like this, you can actually put this in y sub 1 and this in y sub 2. And this, what's y equals 30? It's a horizontal line, right? So and this is an exponential graph of some kind, true? So that means the graph goes like this, okay, and then I have 30 somewhere up here. So really, to figure out my answer, what am I looking for? Yes, the point of intersection. So we're going to go into y equals, and I know we had that other formula in there, so we're going to take that out, and I'm actually going to put this part in. So do you see why I didn't multiply this by 5? I don't want to adjust my window for 150. You can, I just don't want to. Why? I don't know. I just don't. Besides, all I need to do is put in 1/5, right? 1 over 5, parentheses, whoops, lie, delete, parentheses, e to the 5x, doesn't matter what the variable is, minus e to the 5th. And then I'm going to put 30 here. So I'm going to go look at my window. This is a y value, right? So we know that exponential graphs are going to shoot up pretty quick. So your x values could be from 0 to 10, 0 to 5 maybe. It just depends. So you might have to play with it. So I made mine 0 to 10. And then I made this max, my y max, I went up to 35. There's a couple different things that you could do here to take a look. You could you can make this scale 0 and make this scale 0. And basically what that means is you're not going to see every tick mark on the x and y axis. Does that really matter? I mean, you're calculating the point of intersection. So then it just helps open up your graph so it doesn't seem all crunched in there. So I'm going to see what I get. Okay, there's my exponential. There it is. So now I just need to calculate my point of intersection. So remember, I'm looking for a positive value c. Meaning, what does that number have to be? That's going to be that upper bound. So you go into second trace, 5, enter, enter, enter. What's my value? Yep, 1.1396. Yep. So we would just say that c is equal to 1.1396. So I've shown you in your calculator finding the area under the curve using the integration, and then also a graphing function.
To find the intersection, do you have to change the domain?